pleasant day again to everyone. So I'm here again to present and explain to you how to find the area or approximating area using Riemann sums. So this is a PowerPoint video presentation by yours truly, Mr. Gilongos. So area approximation using Riemann sums. So there are steps in approximating the area of the region using Riemann sum, but we can solve the answer exactly using definite integrals. So first step, we divide the interval, the closed interval AB, into n subintervals whose common width is delta x. Okay, so delta x is the width of the rectangles, and the formula for delta x is quantity b minus a, quantity divided by n. So step number 2, make a table and use the formula for the Riemann sum. Summation of x of I, f of x of I, delta x, where I is from 1 to n. Or we can factor out delta x here outside. So another formula is delta x times the summation of f of x of I, where I is from 1 to n. So let's solve the first example. Find the approximated area using the three methods. Letter A, using left endpoints. Okay, left at endpoints. V, using right endpoints. And the third one, using midpoints of the region under the curve y equals 2x plus 1. So this is a line whose slope is positive 2, so it is increasing to the right. Then over the interval, close interval, 0, 5, with n sub-intervals. So there will be 5 rectangles, no? Vertical rectangles. So here's the solution. So first, we compute for the width of the vertical rectangles. So we have 5 rectangles, vertical rectangles, and the width is equal to delta x. So the formula is open quantity, the upper limit, which is 5, minus the lower limit, which is 0. So close quantity divided by n. So our n here is also 5. So quantity 5 minus 0 divided by 5 is equal to 1. Therefore, the width of the vertical rectangles, so there are 5 vertical rectangles and their width is equal to 1. So the first method, using the left endpoints, we have the following x values and corresponding heights. Here's the table of Riemann approximation. So we have 3 columns here. The first column is the I, or the end or the ith rectangle. The second column is the x of I, the value of the x or the x coordinate. And the third column is the f of x of I. It is just simply the value of y. So first, since we have n is equal to 5 here, so we have 5 rows now. So 1, 2, 3, 4, 5. Okay. Then for our second column, we always start with 0 for the left endpoints. Okay. Then to find the f of x of I, since our function is y is equal to 2x plus 1, we simply substitute the value of our x. So x is equal to 0. So 2 times 0 is 0. Then plus 1 is 1. Okay. Now for the second value, we have again 0, 1, 2, 3, 4. Since our delta x here is equal to 1, therefore, okay, the difference between our x of I is also 1. So Substitute to find f of x of I. So 1 times 2 is 2 plus 1 is 3. So we get 3. And for the third rectangle, we have x of I is equal to 2. So again, substitute to our given function. 2 times 2 is 4 plus 1 will give us 5. Then for the fourth rectangle, we have x is equal to 3. Again, substitute here. 3 times 2 is 6 plus 1 will give us 7. And last, for the fifth rectangle, we have x is equal to 4. Again, substitute. We have 4 times 2 is 8 plus 1 will give us 9. And finally, to find the approximated sum or area, we simply add the third column. So we have 1 plus 3 is 4, plus 5 is 9, 9 plus 7 is 16, and 16 plus 9 is 25. Therefore, the approximated area using the left endpoint is 25 times 1, summation of f of x of I times delta x, where I is from 1 to n. So that is 25 times 1 will give us 25 square units. So using the left endpoint, the approximated area is 25 square units. Now, the right endpoints, we have the following x values and the corresponding heights. So again, we have the table have 3 columns and how many rows? 1, 2, 3, 4, 5 rows. No? So since we have n is equal to 5, so therefore our number of rows is also 5. For the second column, we have the x values. Our delta x is equal to 5, upper limit is 5, and the lower limit is 0, divided by n is also equal to 5, so that will give us 1. So the difference between the left and right endpoint is that in the left endpoint, we start with 0. On the other hand, using the right endpoints, we start with 1. And using the difference, delta x equal to 1, so we also add 1 starting from 1. So we have 1, 2, 3, 4, 5. Unlike in the left endpoint, we start with 0, then 0, 1, 2, 3, 4 only. For the third column, this is f of x of I, so this is simply the value of y. Again, our given function is y is equal to 2x plus 1. So simply substitute each value of x to find the value of y. So if x is equal to 1, substitute, we have 2 times 1 is 2, plus 1 will give us 3. Now if x is equal to, if x is equal to 2, again substitute. So 2 times 2 is 4, plus 1 will give us 5. Okay. And if x is equal to 3, substitute to our function. So 2 times 3 is 6, plus 1 will give us 7. Then, fourth rectangle, if x is equal to 4, 4 times 2 is 8, plus 1 will give us 9. Finally, for our fifth rectangle, if x is equal to 5, 5 times 2 is 10, plus 1 will give us 11. Finally, to find the approximated area, simply get the sum of the third column. So we have 3 plus 5 is 8, plus 7 is 15, 15 plus 9 is 24, and 24 plus 11 will give us the answer, which is 35. Okay, let's erase first the writings. So therefore, the approximated area is, again, summation of f of x of I times delta x, where I is from 1 to n, so that is equal to 35 times 1. So the answer is 35 square units. So as you can see and observe, the area approximated using the left endpoint is 25, while for the right end is 35. Now for the third method, using the midpoint, so we have the following x values and corresponding heights. Okay, so again for the first column, so since our n here, okay, so since our n is equal to 5, so we have 5 rows, 1, 2, 3, 4, 5. And since our delta x is equal to 1, okay, for the second column, the difference is also 1. Now to find the first value, as you remember, in our left endpoint, we start with 0. And for the right endpoint, we start with 1. Now for the midpoint method, we simply get the average. That is to add 0 and 1, then divide it by 2. That will give us 0.5. So for midpoint method, we start with, or we use 0.5 as our starting point, no? For our second column. So we add delta x here, which is equal to 1, so we will get 1.5. 1.5, 2.5, 3.5, and 4.5 for our x values. Now for f of x of I, so again, that is simply the y value, and our given function is y is equal to 2x plus 1. So simply substitute each value of x to the value of in our given function. So we have x equal to 0.5 times 2 is 1. 1 plus 1 is 2. Now for the second x value, that is 1.5. 1.5 times 2 is 3, plus 1 will give us 4. For the third x value, that is 2.5. 2.5 times 2 is 5, plus 1 will give us 6. Then for the fourth x value, we have 3.5. 3.5 times 2 is 7, and 7 plus 1 is 8. Lastly, for the fifth x value, we have 4.5. 4.5 times 2 is 9, and 9 plus 1 is 10. Finally, to get the approximated area, we simply get the total or sum of our third column values. So we have 2 plus 4 is 6, and 6 plus 6 is 12. 12 plus 8 is 20, and 20 plus 10 is 30. Therefore, the approximated area, okay, eraser, approximated area using the midpoint method is summation of f of x of I times delta x, where I is from 1 to n is equal to 30 times 1, and that will give us 30 square units. This is the end of the video. Please like, share, and subscribe to my videos. Thank you very much.